So good morning, guys. Today we have Christie Hegermiller with me today. She's a physical oceanographer with USGS, and she's based in the Woodholes Coastal and Marine Science Center. And today we got three questions for her. The first one is, tell us a little bit about your research.
Okay. Hi, everyone. So I'm a coastal physical oceanographer, which means that I'm interested in physical processes in the ocean. Those things include waves, currents, tides, sediment transport, and how all of those processes interact with each other. My research in particular focuses on everything that happens to ocean waves that you would see on the beach, from when they're generated far at sea from a large storm, to when they break on our coastline and they move sand around and they change our beaches, right? So there's lots of different processes that waves experience as they make that long journey across the Pacific Ocean or the Atlantic Ocean from when they were generated to when they get to our coastline. They interact with the currents, they interact with the winds above them, they interact with each other, they change their shape, they change the amount of energy that they have, right? So my research in particular focuses on using numerical models which describe in mathematical terms all of these processes to predict and understand waves from past storms and future storms and how the coastline changes in response to that. What that really means is I'm studying things like barrier island breaching, dune erosion, overwash events when waves come over the top of a dune and put sand in the backside, and changes to, say, the bar that's in the water when you go swimming. So, right, if you walk into the water, it'll go down at first, and maybe sometimes you'll come back up, right? And that's because there's this big bar there underwater. And so I study how that moves as well. All of these things are important because they change our coastline and because we have homes and critical infrastructure of our communities right at the coast. So we really need to understand the physics that drive how our homes and our infrastructure are threatened or protected by during big events or even just regular seasonal changes in beach.
Okay. So the second question is, how did you get into science? Or another way of saying that, what inspired you to be a scientist?
Okay. I spent a lot of time on the water as a kid and on the beaches as a kid. I had a small little sailboat that I sailed with my dad a lot. And we took it out in all sorts of wave conditions and wind conditions, and we capsized. And I felt a deep intuition for the water as a kid. And my mom will describe me as a child on the beach, just constantly looking around and curious about what I could find, or um, inquisitive about why the beach was different that time than the time we've been there before. And that inquisitive nature, I think, carried me through in all aspects of my life, right? So it's not just the ocean, but you as a student or someone else might be interested in anything that is around them in your world, right? You might be interested in how that works. And that could be like the gears on your bicycle, that could be like the trees around you or plants in your garden. And that curiosity about how things work, that's what a scientist is, right? That's all that it is. And these particular avenues that we pursue are just the things that we're most passionate about. So for me, that was the beach and waves. But for someone else, your curiosity might be about a million other things. And that curiosity is really what gets you from, this isn't the life I'm living to why is this the life I'm living, right? Why is this what's around me? And so I've just taken that and I've made that into my career.
That sounds awesome.
It's fun.
All right. The final part is talking about one of the 8 science and engineering practices. So there's 8 practices, and one of them is about communicating information. Could you talk about a little bit about that and how it works in oceanography?
Sure. Yes. So being a scientist, right, is being curious, but then asking specific questions, designing an experiment, coming up with results, and drawing conclusions, right? So it's not just, why is my garden growing well this year? It's, let me figure out exactly what that is, right? And once we have those conclusions, we need to communicate them. We need to communicate them with our peers in science, so other experts in oceanography, particularly coastal physical oceanography, which I study. I also need to communicate that with local communities or local government officials, or even federal government officials as a scientist at the U.S. Geological Survey, so that they can make informed decisions about how to protect our coastal communities and the coastal infrastructure that we have. So there's two ways of communicating that are very different from each other, right? One, with my peers through the format of academic journals, where I write up all of my methodology, all of the results that I found, and I submit that to this journal. Before that paper, this article gets published and broadcast to the rest of the community, it goes through a process called peer review. Peer review is the journal asking me as a scientist to review someone else's work, right? So my work will go to someone else, and that person will ask whether or not the experiment that I designed is well suited to answer the questions that I'm asking, whether or not I considered all the limitations, right? Whether or not I drew conclusions in an unbiased way. So that's one avenue, right? Is going through this peer review process in an academic journal. And this is dry technical language, right? So that everyone understands every detail of what you did, so it's reproducible. The other avenue is this communicating with local communities and local government officials. And that's often with very different language, different words, different styles, different emphasis on parts of my work. And I'm obligated to do that as a federal scientist, right? So I need to be doing research that's tangible, that's usable by other people to protect our environment and our communities. And that style of communication often looks more face to face. There's a lot of conversation. There's a lot of simplification of the results, so it's not confusing, and trying to weave in all of those parts of the uncertainty, the potential errors, the limitations, make them really tight, not minimize them, but make them really clear so that we can actually do something, right, with the results that I have. So that's a little bit about how my work functions as far as communicating the results of the science that I'm performing.
All right. Well, thank you so much for sitting for this interview and talking about the practices and how you got into science and your research. So thank you very much.
Absolutely. Thank you.